We're studying IGCSE physics and we're starting electricity, division 1. In this chapter, we're going to learn all about what electricity is. Let's see. We're going to look at electricity. The objective of today's class is electricity. Then we have charge. Then we have voltage. Then we have resistance. And before voltage, we have something called current.
Sir, are these the agendas for today?
Not for today. We'll try to finish at least this much. All right, till current. It depends how much you can understand, right? If I see your understanding, we'll go faster. If I see you're having doubts, we'll go slower. Now we'll start with electricity. Just a second. First thing first. We'll start over. Yeah, all right. Let's see. Can you see the book?
Yes, sir.
Now, in electric charge, the first thing we're doing is electric charge. Now, okay, what is electric charge? Write the definition in your notebook. Electric charge is basically it's a magnitude that is always there in an electric field. Okay, electric charge can be of two types. Electric charge is of two types. Now, what is electric charge? You don't need to know that. It's like mass, right? Everything has mass. We don't say what is mass. Mass is basically the amount of substance in something. Well, this would be the property because of electric field.
Sir, the definition for electric charge is?
The definition of electric charge is the property because of an electric field. All right, they don't ask you this in the exam. All right, you don't need to know what electric charge is. But what is electric charge? It is basically if you have an electric field, then inside that field, everything will have some sort of electric charge. Is that clear? So if you have an electric field, like gravity, gravitational field, everything inside gravitational field has mass, right? Everyone has mass. Like your water bottle, you, your parents, everyone has mass. In the same way, if you look at an electric field, we'll see what that is. Everything inside that electric field has electric charge. We'll get to that later when we talk about electric field. Any questions? Now, these are of two types, positive or negative. Okay, all right. So how many types are there? Mavadda, tell me.
Negative and positive charge.
Negative and positive charges. Now, one thing we will actually be focusing on in our classes or in your syllabus that they focus on is unit charges. Now, what are unit charges? Unit charges are basically perfectly spherical charges, magnitude 1. Now, you don't have to write this. Please don't write it. They won't ask you this in the exam. I'm just telling you what a unit charge is. Unit charge is like a ball. It's like a sphere, okay? And it's like a ball. I can't show you a ball right here, but what I can show you is the circle, the outline of the sphere. Now, it has one charge. So it's either +1 or we can also have a negative one of this, which will be -1. -1. Now, the first thing we need to realize in this is how does electric charge work and what is electric charge? We know what electric charge is. It is something that everything has in an electric field. All right. Now, we know that there are two types. Perfect. All right. Now, let's see some rules. Write this in your notebook. Rule 1. I want you to write all of this and all of this. Now, the next thing we need to learn about is the first rule, that like charges attract unlike charges repel. No. Like charges repel, unlike charges attract. Now, what does that mean? That if you have two positive charges, they're going to repel each other. Lula, what is the meaning of repel?
When we have two positive charges, they repel, like they move far away from each other.
Yeah, they push each other away. They're not attracted, they don't pull, they push. So this is basically push, while like charges attract or pull. Now that's just to explain it to you. We need to know what repel means. Repel means to push away. Now write this in your notebook, tell me when you're done. Next thing is we'll realize, now we know what charges are, okay? They are positive, negative, they are there in electric field, fine. But where do they come from, right? Let's see. Where do charges come from? Well, these charges, they come from inside the atom. Okay, they come from inside the atom. Let's look, we'll have to look at an atom for that. Let's look at an atom. Just a second. Can you see the diagram on the screen of an atom? Mavada, can you see an
Yes,
atom
sir.
on the screen?
Yes.
All right. This right here is what we call an atom. And it has electrons and protons. Fine. Protons are, we know that already from chemistry class, that these are positive. 1, neutrons are 0. Electrons are, Diana, what is the charge of an electron? Diana, charge of an electron?
Negative.
Negative 1. Let's just write it here. Charges of nucleons. Now, you must have this in chemistry, but fine, we're doing it again today. So we write proton is equals to +1. Neutron is nothing, 0. No charge is neutral. And electron is negative. Okay. Now, if I want something to become charged, there are a few things we can say. Okay. If I want positive charge, positively charged, or let's say I have a rod here. Let's say I have a sphere, actually, like this. And it's standing on a stand like this. In this sphere, we have some charges, plus, plus, minus, minus. Now, can you tell me how many positive charges are there?
2.
2.
2.
How many negative?
2. 2.
2. So if I add these together, 2 times +1 and 2 times -1, I'll get a charge of 0. Therefore, this is neutral.
Neutral.
The overall is neutral. Fine, we know that. Next thing is, well, it's neutral. How can I make it positively charged? If I remove one negative, now I have 2 + 1 and only one negative. Therefore, it will give me a +1 charge. So now this is positively charged. Is that clear? Because I have more positive than negative. Any questions?
No, sir.
Just a second. Now that's positively charged. What if I do one more thing? And if I make it 2 minus and 1 plus, therefore that will become now negatively charged. Now these are ways we can make things charged, positive or negative, by removing a positive or negative charge. But you'll realize in the real world, it's much more difficult to remove a proton, a positive charge. And inside the atom, what has positive charge? Protons, right? These guys, this one. So if this atom has, if this proton has plus charge, and if I want to make this this sphere negative, I'll have to remove this plus charge. So if I remove it from here, let's say I take it outside, now it's negatively charged. But how the heck can I take a positive charge outside? Because it's inside the nucleus, which is very tiny and very strongly put together. So I can't really remove a positive charge, but I can do something instead. what I can do is I can add a negative charge. But it's very easy to add. Let's write it here. Easy to add or remove negative charges. Now, Diana, what do I mean by this? Easy to add or remove negative charge. What is the meaning of this? Diana?
Like it's very easy for us to remove the charge.
Not charge, but negative charge. What I mean by that is it's very difficult to remove a positive charge. Why? Because it's inside a nucleus. But if I have electrons, they're actually outside the atom. So it's very easy to pull them out or put them inside. So what you can do is you can easily add them or you can remove them. Look, electrons are over here. So what is easy to remove? The positive charge or the negative charge? So I can remove this much easier than I can remove an atom. So therefore, whenever we're trying to charge something, we can't remove positive charges, but we can remove negative or add negative charge. Is that clear, Lula? And Mabadda?
Yes, sir, it's clear.
All right. Now, these negative charges are basically electrons.
Sir, do we have to draw all of this?
No, not right now. Not right now. You need to understand what happened, right? Not right now. I'll tell you what to do. Now, let's start with how can I make something charged? I know what charges are. I know how they're caused. I know that they're caused by electrons and protons. But I can't remove protons because, well, they're inside nucleus. But I can add or remove negative charges by making this sphere negative or positive. Well, let's look at how to charge things, which also means induction of charge. This is in your syllabus and you need to understand this. Now, Mawadda, have you done this in class already? Mawadda? Induction
Yes,
of
sir.
charge? Now, can you tell me something about it?
No, sir, we haven't done it.
You haven't done it. Then how did you reach resistance? All right. Haven't you done, let's say, polythene is rubbed against something and that thing gets charged? We'll look at it, never mind. Let's see, now I have this rod here. Let's think this is a polythene rod or a plastic rod, all right? And let's say it's right now it's negative, it's neutral. I have a neutral rod. Now tell me, is this neutral or is it positive or negative? Quick.
It's positive.
Positive. Let's remove one more. Now is it
Neutral.
Yep. Now what happens is I can do one thing. That is, let's say, what I'm going to do is I'm going to take something called a wool. Okay, wool. And there's one property of wool. If you rub it against something, all right. If you rub it against something, what happens is it pulls all the electrons out. What does it do?
Pulls all the electrons.
All right. So let's take this wool right here, and I'm going to rub it here. Now this wool is also going to be let's say neutral plus. Now if I rub it like this, what's going to happen is all the electrons are going to go from the wool to the rod, the plastic rod. Okay, so the electrons go from wool to plastic rod. If I rub it, let's write it here. So when I rub it, these guys go from here to here. Now I'll show another diagram right here. Step 1 was rub together. Next thing is step 2. What happens is your rod will look something like this. It will now have 3 negative charges, 3 positive charges, but extra negative charges from the wool, the green ones. which I got from here. Now, can you tell me what is the charge of the rod? And what is the charge of the bull? Just a second. We have plus, plus, minus, minus. So now we're left with only plus, plus here. So what is the charge of the bull and the charge of the plastic rod?
The charge of the wall is positive and the charge of the rod is negative.
Negative. Fine. So now magically, well, it's not magic, it's science. By science, I just brought electrons here. Now this is negatively charged and this is now positively charged. Perfect. Okay, that's one way to cause induction. Now, this is not the best way to write it. I'll give you a two-step method, which you need to write here. The method is, or the question, write it as a question and the answer. The question is, how is plastic rod, how does plastic rod become negatively charged by rubbing with wool? Now, 3 marks. This question exam is always 3 marks. I know what the questions they are going to ask you. This is a classic question. So what you're going to write is when, or instead of saying plastic, let's use the word polythene because that's what your exam is going to ask you. So when polythene is rubbed with wool, woolen cloth, electrons are pulled off from wool to polythene cloth. All right. Thus, therefore, let's say thus, rod becomes write this in your notebook. Tell me when you're done. Any questions? Mawadda, read it from the beginning once.
How does polythene rod become negatively charged by rubbing with wool? 1. When polythene is rubbed with woolen cloth, electrons are pulled off from wool to polythene rod. Thus, polythene rods becomes negatively charged and wool becomes positively charged.
All right. Any questions? I think that's easy, right?
Yes.
Now, okay. Now we have one more thing called perspex. We have polythene. We have perspex rod. Now it's exactly the same. It's but quite a little different. Now electrons are pulled off from the perspex rod to wool. Thus, perspex rod becomes positively charged. Write this in your notebook. And wool becomes negatively charged. But actually, wait for a second. Write it like this. I want you to put brackets here. So what this means is that you have 2 options, either perspex or polythene. How do we read this answer? Let's say if you're reading polythene, then you have to read the first one. First option. This one and this one. But if you're reading for perspex, all you have to do is read the bracket part instead of this one. Any questions? Do you understand what I mean? Now there's a
So
clear
it will
difference
be
between,
like when
yeah.
when Perpex is rubbed with woolen cloth, electrons are pulled off from the wool to Perspex
No,
Perpex rod.
just a second, sorry. What you have to see is, let's put brackets here as well. You have to choose between these options. Fine? Because exactly the answer is exactly the same, but all that's happening is you have to choose between the bracket parts. Fine? Now, Mawadda, read for the polythene. So always read the one before the slash sign. Quick read.
When polythene is rubbed with woolen cloth, electrons are pulled off from wool to polythene rod. Thus, polythene rods become negatively charged and wool becomes positively charged.
Now, Diana, read, or Luna, read for Perspex rod.
When Perspex is rubbed with woolen cloth, electrons are pulled off from Perspex from wool to okay. Electrons are pulled off from Perspex. Thus, Perpex rods become positively and wool becomes negatively charged.
Is that clear? Now, I think if
Yes,
it's
sir.
confusing, you can write it separately as well. Is this fine? You understand? So
I
this is with,
understand, but I'll write it separately.
write it separately, all right, then that's fine. Just a second then. Now you have the two options here, all right? That's it. Now, Mawadda, any questions? Diana, any questions?
No, sir.
No, sir.
Now, next thing is, fine. We're starting conductors. And insulators. What are conductors? Keep writing, finish writing that. Conductors are basically things that allow electrons to pass through. All right? Let's just say things that allow electrons to pass through. Metals are good conductors due to, what would you say? Free electrons. Now this question is for 3 marks, therefore 3 points, right? In the exam, whenever you have a question which is, let's say, 3 marks, you should write 3 points. Don't write it like a paragraph. Well, I'll see that when you finish the tests and stuff, I'll give you feedback, but just write your answers as bullet points. Okay? Now, Luna, have you done any tests with me? I don't think so, not yet, right?
Test, I don't think so, but for chemistry, when Diana was not there, we finished the chapter metals and you gave me a past paper test. Not like a test, but like a revision.
Right, like a quiz, all right. Okay. Now those are easy. Those are nothing like my tests. Okay. So when we finish the chapter, since metals are done, I'll take the test. And the key thing is not just answering questions. The main part is, Diana, you listen to me. It's about organizing your answers properly, right? Because
Yes, sir.
what happens if you write the correct answer, but you miss a few words, or if the examiner does not like your answer, right? So the examiner must like your answer, and you should have a very clear and perfect format for each answer. No random answers, right? Now, have you finished writing, Diana? Mawadda?
Yes.
Yes, sir.
Now, insulators, let's just say, do not allow electrons to pass through. Why? Because no free electrons. It's easy, right? No free electrons or free electrons. If you have free electrons, you're a conductor. If you don't have free electrons, you're an insulator. Finish writing this. And the next thing we're looking at, I'll give you some examples of these, right? So you know what conductors are. Write the examples quick. Examples are metals, all metals, and you'll have graphite as well. Example of this is going to be plastic, wood, perspex, polythene, all of those. The perspex and polythene are two types of plastics. We saw two types of rods. We saw a perspex rod and a polythene rod right here. Now both of these are kind of a plastic, but one, let's say, pulls electrons, while the other one does not pull electrons. It loses electrons easily. That's why when I rub the wool with polythene, it pulls all the electrons. On the other hand, just a second. Have you written this properly? Check step 2 of second question. Have you written this properly, Mawadda, Gianna?
Yes, sir.
All right, then let's move on. Next thing is electric field. All right, before we do electric field, let's also look at two more things. Well, we already looked at.
Question
Yes, ask me.
for the conductors part. We know
For
that all the alkali metals are metals.
Right.
They're all metals, right?
Yes. All of them are
among
metals.
these
Yes.
metals, all
Yes.
of them are conductors, or like they're the weakest. That among them there are weak ones.
There are weak ones. Yes. Copper is the best conductor. Not copper, silver, but you should just remember copper in your exams. So look.
So even though they're all metals, some of them can conduct and cannot.
No. They all conduct, but some of them are better conductors than the others. Right? Understood? So copper is best conductor.
Yes.
That's why we make wires with it, right? Remember, we make electrical wirings with copper because it's a good conductor. It's a very good conductor. Compared to aluminium, compared to, let's say, iron, obviously copper is better. I hope that answers your question. Next one is, we're looking at electromagnetic, or let's say, induced charges. Now we looked at how to get things charged by rubbing them, but we can also induce these charges without rubbing. I'll make another sphere for you, and right here, let's see. Now this is what the exams are actually asking a lot more. Now I'll have a sphere right here. Let's say randomly charged plus, minus, minus, plus, minus, plus. Mawadda, what is the charge of the sphere?
Negative.
Negative. Negative? Yes. And now?
Neutral.
Yes. Neutral. Now I have a neutral sphere. How can I make it positive? That's my question. I can't rub it with a rod. That's not really possible because it's not something which is easily able to rub. Like wool, I can wrap it around the rod and I can rub it. But what about a sphere like this, a metal sphere?
Earthing?
So first I'm going to, tell me.
Will earthing?
Go on. One more time.
With a charged positive rod?
Yeah, with a positive rod. We'll bring it, but I want to make it permanently charged. Let's see what happens. Just a second. Now, if I say or let's say, okay, fine. Look, let's take all of this from here and let's bring it here. Now what happens is, if I bring it close here, okay, let's say if I bring it close, then what happens after in one step is that positive charge is going to attract which charge? Diana, tell me. Positive charge will attract which charge?
Negative.
Negative. So what happens is all the negative charges come over here up, and all the positive charges go away because it repels all the positive charges, right? If I bring positive here, all the positive charges go away. So now this is what it looks like. This is fine. This is what it looks like. Now, okay, but the rod is still neutral, right? It's not positive or negative. But I can do one thing. I do realize one thing, that if I divide the rod into two parts, let's say like this, then the top side is negative and the bottom side is, tell me, positive. The bottom side is positive. Now, what I want to do is I want to make it negative only. So how can I do that? The next step is called earthing. Mawadda, do you know what earthing is?
Yes, sir.
Tell me.
We connect the object with like we connect it to the earth.
Connected to the
And
earth
we-
like this. And
Yes.
now let's call this the earth. Okay.
Conducting
And if I
material.
connect it with it, let's connect it with the earth, and we use, let's say, a wire, something. You can also use your finger if you want, but you must be connected to the earth. Your feet must be touching the ground. And now what this does is, this allows you, this gives you a path for the electrons to flow. Okay. What does it do? It gives a path for electrons to flow. What happens is this part of the sphere is negative. The top is positive, top is negative, bottom is positive. What happens is electrons from the ground, they come and they go to the positive side. Okay. And then what happens is, we get a rod like this. Get a sphere. Our sphere looks like this now. All the positive charges are gone, and we only have negative charge here, and this is your rod. What is the next step? Next step is I remove earthing. Let's say after this, actually, remove earthing, and I'll be left with this sphere, right? Any questions? Now we
No.
started with a neutral sphere, and what happens was it pulls all of the electrons together. Then I connect the earthing, and then electrons come from the wire to the sphere, and then I remove the earthing, and I have myself a sphere like this, which is now negatively charged. Okay. Now, okay, let's write this as a few steps. Lula, any questions here? Let's look at this part again. Can someone tell me why do electrons come from the earth to the sphere? Why? Answer.
Wait,
Or should I tell you?
can you repeat?
I'll repeat. Why do the electrons come from the earth to the sphere? Why do electrons?
Because the sphere doesn't contain any.
Well, the sphere does contain any. Look, it has the positive, negative charge above. It has these electrons, right? Negative charges are basically electrons. Because we know negative is because of the electrons. Okay. If I already have electrons, why are more electrons coming? Mavada, Diana?
Sir, I
The
don't know.
answer is, I'll tell you. The answer is going to be because electrons come to fill positively charged areas. All right. Read this out loud, Lula, from the beginning.
Why do electrons come from Earth to sphere? Answer, because electrons come to fill the positive areas.
Positively charged areas. So positively charged areas. Now the issue is this is positively charged, and these charges are now fixed. They can't move. Okay. Well, usually what will happen is that these guys will go there and they will balance out like this. Look, they will become like this. Some is up, some of the charges above, some are bottom. They will balance out. But that cannot happen because all of these are being pulled from this. Okay. Since they're stuck here, more electrons need to come to fill this area, and this is what it would look like. Now, since we know that positive and negative cancel out, so in the end, what are we left with? We're only left with negative charge above. Over here, if I didn't show you, but we do have this. So they're balanced. It's not positively charged anymore. It becomes neutral, so we don't have to show it. Is that clear? Do you understand? Now,
Yes.
explain to me, Diana, why do electrons come from Earth to the sphere?
Because electrons come to cover the areas that don't have charge.
Yeah, they don't, which are positive. So it's like positive. The electrons are attracted to the positive side because we know that positive and negative attract, right? So this positive charge will pull all the electrons from the Earth. All right. Now, if I write this as the steps, how is a sphere, let's say, negatively charged using positive rod? This is a 5-mark question in the exam. Write the answer. First thing is bring rod close to sphere. Bring positive rod close to neutral sphere. Second step is electrons are pulled close to the rod and sphere. Let's say and top of sphere becomes, or let's say negatively charged, or let's say sphere becomes Diana, read from the beginning.
How is a sphere negatively charged using a positive rod? Bring positive rod close to neutral sphere. Electrons are pulled to the rod and sphere becomes partially charged. Negative close to rod and positive away from rod. Connect earth electron.
Now keep writing. Finish quickly, and this let's say 25%, 20% of the chapter is done. electrons come from Earth to fill Lastly, remove earthing first, and then rod. Rod is now. That's it. Nula, read the third point.
Connect Earth. Electrons come from Earth to replace missing electrons at positive areas. And
Okay,
number 4,
Mavadda, read the fourth one.
The first one?
Yes. No, not the first one, the fourth one.
Oh, the fourth one.
Yes.
Remove earthing first and then rod.
Why is that? So electrons do not, let's say, don't leave. Okay, is that clear? Now we look at that again. Why we remove everything first and not the rod first. We'll do that. Have you finished writing, Diana, Lula, this part?
yes, sir.
The rest of you? Mavata?
Yes, sir.
Yes, sir.
All right. Now read the second one from the beginning. Mavata.
Electrons are pushed away from the rod and sphere becomes partially charged,
Partially.
partially charged. Positive close
Positive.
to rod and negative away from rod.
All right, stop. Now connect earth electrons leave sphere. Leave sphere. Why do they leave sphere? Because to, let's say, remove extra electrons at negative areas. Remove everything first and then rod. So electrons don't, let's say, come back. Now I'll just show you one diagram here. This is exactly the same thing happening, but Diana, can you tell me what is the difference between this one and this one? 1 and 2. I need all of you to tell me what is the difference between these two? These two answers.
The first one, we're bringing, like, we want more electrons, and the second one, we're removing electrons from the sphere.
Right. So we're causing, first we're bringing a positive rod, and then the electrons are, more electrons are coming to the sphere. And in the second one, we're bringing a negative rod and we're removing electrons from the sphere to make it positively charged. Now, just a second. I think that's all you need to know. But we'll look at one more thing. I'll show you what happens. Look at this diagram right here. You have a sphere, and right now what's happening is you have a rod here as well. Let's say this is positive, and let's say this is negative actually. and all the positive charges or all the electrons leave from here. They go away. The positive don't come up actually, or the electrons go down. Right? Now tell me, what is the next step from here? I want to make the rod positively charged. It's neutral right now. What is the next step, Lula? Mabadda, Diana, tell me.
We
connect the
we want
earth.
to make it, yeah, we
We
connect it
connect
to
the earth.
everything.
Yeah.
Connect the earthing. Now, okay, if I connect the earthing, Diana, tell me what will happen if I connect earthing. I have positive
It will
here.
lose the positive charge.
It will, say that again.
Lose the positive charge.
Well, I'll tell you why that will not happen. Why? See, now the positive charge are pulled by the rod, like they're being pulled up. So there's no way they're fixed. They cannot move. And positive charges never come or leave because I know they're always fixed. The only thing you can do is you can add electron or remove electron. So what do you think will happen here? Will the more electrons come in, or will electrons leave to make the rod positive? How can I make the rod positive?
We have
will
to,
leave.
yeah.
So electrons go to Earth. And what happens after that is we get ourselves a positive rod. Any questions, anyone?
No, sir.
Now
No,
there's a
sir,
key step here. There's a key step here, which is always asked in the exam. Now, what will happen if I remove, this is what I have now. So should I remove the earthing first or the rod first?
earthing, the earthing part.
But I'll remove the rod. Now what will happen? Tell me. If I remove the rod first, what will happen?
The electrons will come back. No.
Because look,
they're-
because it's positively charged, and this positive charge is no longer fixed, right? It can move around. Well, it can't really move, but the negative electron, these guys are not pushing it away. Okay, so what's happening is the electrons will now come back to replace the missing electrons, because electrons left, right? And now the sphere is positive. So the Earth does not want anything to be charged. They want to make it neutral. That is why they remove the charged electron from here. But they cannot do anything about this space, because if electron will go there, then the rod will push it away, right? Because the rod is negatively charged. So if electron came here, it will be pushed away. So there's no way I can remove the, I can make that side positive, or I can make that side neutral. But over here now, since there's no rod to push away the electrons will come back, and I'll have a neutral rod again, a neutral sphere again. Is that clear?
Yes, sir.
Because I remove the rod, the positive charges are no longer, let's say, being attracted or fixed because of the rod. So electrons will come back. I don't want that to happen. So therefore, I remove the earthing first. And if I remove the earthing, then the electrons cannot come back, and it is positively charged. All right. Now that's enough for this one. We look at a question, a few questions in a few seconds. But let's start with unit of charge. Write this in your notebook. The unit of charge is, first let's see SI. SI unit is coulombs. It has the symbol C. All right. Now what we need to realize is coulomb is a very big charge. Okay, coulomb is very big. So usually when you, let's say, the charge in the wire in your home are not nowhere near coulomb, they're in micro coulomb. Now do you guys know micro, milli, peta, all of that?
No, sir.
Let's start from here. So we'll have meter, let's say any substance, we have meter, then we'll have centimeter, we'll have millimeter, then we'll have let's go downwards actually. Millimeter, micrometer, we have nanometer, Then we have picometer. Write this in your notebook. This is revision of recap chapter 1. Because we need this in this chapter actually. So CH1. So don't worry if you haven't studied anything. We'll cover that. We'll revise it. Now finally we have kilometer. We have and then we have gigameter. Then we have terameter. Now this one is called tera. Make this in your notebook. Tera. Then the next one is called giga. Next one is called mega. This one is called kilo. This is nothing. This is called milli. This is called micro. This is called nano. This is called pico.
Micrometer is like milli, mm.
Micro is different. Just a second. This one. Look. Let's make arrows. So this is with this. This is with this. This is with this. This. This.
No, I
This
just
is
want
with
to know the
this.
short form
Which one?
of micro.
Micro is a separate thing. It has this symbol, micro. Okay. So make that symbol. In the exam, you'll be using it. It looks like this. Let's say it looks like this. That's called micro. Now this is 10 raised to power minus 3. This is 10 raised to power minus 6. This is 10 raised to power. This is nano, by the way, nano. 10 raised to power minus 9. This is 10 raised to power minus 12. Now, Mawadda, do you know all of this already? Are you comfortable with this? Any questions? Now, what I'm asking is, have you done this or do you know this already?
No, sir.
Then, okay, then do it right now. This is from chapter 1. You must know this. There's no way to continue the class ahead, actually. So that's it. This is what you need to know. What does that mean? Well, if I say, just a second. Let's say, please make this table quickly. N is for nano. If I say, how many coulombs is 1 micrometer? How will I find the answer? Not micrometer, sorry, microcoulomb. How will I find the answer? All I have to do is 1 microcoulomb is equals to 10 raised to power. How much? What is the power here? 10 raised to power
Minus 6.
minus 6 coulombs. So 1 microcoulomb is equals to 10 raised to power minus 6 coulombs. Or if I write it as decimals, this will be 0.000000 coulombs. That is how small a microcoulomb is. And usually that is the amount of charge which is being carried in your electrical wires and everything. Clear? That's what's happening. So whenever you want to convert, all you have to do is, let's say if someone tells you what is 1 micrometer, or let's say what is 1 nanometer, how much is 1 nanometer? All I have to do is multiply 10 raised to power 19 minus 9 into meter, which is 0.000001. So 9 zeros after that. 8 zeros and 1. Now this is important to know how to convert between these. If I ask you what is 1 coulomb in micrometer, microcoulomb, sorry, how will I answer this? Well, I know that 1 microcoulomb. Let's write it above. I know that